Hello everyone, welcome to Chemistry Concepts, and this time I came with a new video that is about environmental chemistry, that is especially for BSc students. Going into the topic, that is about an introduction to environmental chemistry. What is meant by environment? Environment means surroundings that affect the existence, development and growth of living organisms. That environment, it comprises of air, water, soil, forest and climate. And this study of various chemical phenomena taking place in the environment and their impact effect on life, it is called environmental chemistry. And what are the consequences? The main consequences are due to water pollution, soil pollution. The water pollution is mainly due to rapid growth of automobile and other industries, which release the harmful gases like carbon dioxide, carbon monoxides and oxides of sulfur and nitrogen and other particulates into atmosphere, which is nothing but air pollution. And the chemical industries, they are also responsible because a large extent they release the harmful wastages into the rivers and lakes, which causes the water pollution. And along with that, soil also will get polluted by the extensive use of detergents, pesticides, insecticides, fertilizers. And all this environmental pollution, it causes ecological disorders and severe health hazard to humans and other living beings. So, diving into the subject, Earth's atmosphere. Earth's atmosphere. What is Earth's atmosphere? Before that, we'll study about its environment. Environment is nothing but an atmosphere, hydrosphere and lithosphere and biosphere. On all these classification, it comprises of environment. This environment is classified into atmosphere, hydrosphere, lithosphere and biosphere. And this atmosphere, it is a protective blanket of gases. Why it is called as protective blanket of gases? Because it stops or emits the absorption of electromagnetic radiations from the sun. That means it does not allow the electromagnetic radiations into the Earth's atmosphere. What are electromagnetic radiations? Normally UV, visible radiations, IR radiations, cosmic rays. These rays will not be allowed into the Earth's atmosphere, and that is why atmosphere is a protective blanket of gases surrounding the Earth. Along with this, nitrogen and oxygen, you are well known with. They are the major constituents of the atmosphere, along with carbon dioxide, argon, water vapor, neon and a few other gases which are present in a small amounts. And then structure of atmosphere. Here the structure of this atmosphere, it extends up to 500 kilometers with a varying temperature from 271 kelvins to 1470 kelvins. And this atmosphere, it is broadly classified into 4 types, that is troposphere, stratosphere, mesosphere and thermosphere. And this troposphere, it lies or it contains about 70% of the mass of the atmosphere. and the temperature of the troposphere falls steadily as the altitude increases, and this is due to fall of pressure and density of the air. And this troposphere, it ranges from 41 kilometer, having temperature between 288 to 215 kelvins. The cold layer or the minimum temperature region is 215 kelvins. At the top of the troposphere, it is called the tropopause. And stratosphere. What is the stratosphere? Stratosphere, it lies above the tropopause, where the temperature increases with increase in altitude, and the maximum temperature seen is 271 kelvins. And that region, it is called a stratopause. That means where the temperature is seen as 271 kelvins. And this warming up in this region is due to absorption of UV radiation by ozone present in this region. Why the temperature is high? Because it is observing the high UV radiations by the ozone present in this region. And the next one is mesosphere. This mesosphere, it lies above the stratosphere, in which the temperature once again decreases with increase in altitude. A minimum temperature as low as 173 kelvins is observed at the top of the region, is called as mesopause, where ozone is absent. And the next one is thermosphere. And this thermosphere, it lies above the mesopause, where the temperature rises rapidly. A maximum temperature of 1470 kelvins is possible. This is about the atmosphere and its structure. And then next one, that is ozone layer. What is ozone layer? Ozone layer is, it is allotropic form of oxygen. It is, and also it is a highly reactive, toxic or poisonous gas. How this ozone layer is formed? Ozone layer is formed by reacting with sunlight in the presence of sunlight, and with a wavelength less than 240 nanometers, it forms 2 moles of oxygen, and then, or otherwise, oxygen, it reacts with 1 mole of oxygen and then with an inert gas to form ozone, that is O3, along with liberation of inert body. What is that inert body? Why we are considering that M? M is inert body, which takes away the excess energy liberated in the reaction, thus stabilizing the O3 molecule form. And this ozone layer, it is present about 25 km from the Earth's surface. This ozone also absorbs UV radiation of the sun and undergoes dissociation. That means O3 plus H nu, it forms O plus O2, and O plus O3, it forms oxygen, 2 moles of oxygen. And the main causes, main drawbacks are what happens when ozone layer gets depleted. Moreover, we get diseases like cancer and eye diseases in human beings, genetic mutation plants, animals and marine life, destroy crops and other forms of vegetations. These are the side effects or consequences of depletion of ozone layer. So finally, how you can conclude this depletion of ozone layer is, the depletion of ozone layer is due to the increased flux of harmful UV radiation into the Earth's atmosphere. That means when the harmful UV radiations enters into the Earth's atmosphere increases, this depletion of ozone layer gets increases. When the entry of harmful UV radiation into the Earth's atmosphere, it gets decreases, the ozone layer depletion will be reduced, and the depletion of this ozone layer is believed to be caused mainly by four reasons. One is nitric oxide, and another one is chlorofluorocarbons, and another one is greenhouse effect or global warming, and the fourth one is acid rains. In our next video we shall continue this classification of nitric oxide, CFC, greenhouse effect, and then acid rain along with the photochemical smog. So see you in the next video. Until then, this is Mahesh signing off.